Okay, in this video we're going to look at finding the limits using a graph. So for f of x as x approaches the value of a, we're going to examine the graph to see if the left-hand limit exists. Now, it's not going to exist if there's a vertical asymptote at that value of x, or that value of a rather. So if the limit, if we have a vertical asymptote there, remember with vertical asymptotes, as we get closer from the left and as we get closer from the right, our y values are either going to skyrocket up forever or skyrocket down forever, but never actually equal that value of a. Also examine the graph to see if the right-hand limit exists, and ditto for the vertical asymptotes there. So again, with vertical asymptotes, if there's one from the left, it's automatically going to have the same behavior as far as that limit, that value not existing from the right. So if the two one-sided limits exist and are equal to each other, then we say there is a limit. So if the left-hand limit and the right-hand limit exist and they're equal to each other, then we say that there is a limit. So that was the implication from the end of the last video. So if there is a point at x equals a and the function is defined for that value of a, then f of a is the value of the function at that point. So again, limits aren't concerned with what the value is at that point. They care about what happens around that point. But to find the value at that point, just look on the graph for where the function is defined there. So example 5, use the graph of f of x to find each. So where we have a piecewise function composed of a parabola in red and a line in blue. So part A, find the limit as x approaches 2 from the left. So here's our 2 on the x-axis here. So as we get closer and closer and closer to that x value of 2, our y values are getting closer and closer to this y value, which is 8. So the limit as x approaches 2 from the left of this function is 8. Part B, let's look at the limit as x approaches 2 from the right. So again, approaching 2 from the right. This time we're going up this line and we're getting closer and closer. And as we get closer to x is 2, our y values are getting closer and closer to this y value of 3. Part C, the limit as x approaches 2. Well, we saw in part A that as we approach 2 from the left, we get a value of 8. And in part B, we saw as we approach 2 from the right, we got 3. So coming in from the left, we got one number. Coming in from the right, we got a different number. That creates a problem because the limit does not exist. Since these two values, as left and right hand limits, are not the same value, the limit of our function does not exist. That's what DNE stands for in this presentation here. So, all right, part D, what is the value of the function at x equals 2? So part D has absolutely nothing to do with limits. But the function is defined here at x equals 2, and we get 3. So f of 2 equals 3. F of 2 could have been up here at 5, and this could have been an open circle here, but in this case, the function is defined at 2 for a y value of 3. Okay. Example 6, here we have a similar looking graph, not exactly the same as you saw from the transition there. So part A, we have the limit as x approaches 2 from the right. So again, coming in, from the left rather. Coming in from the left, we get closer and closer to a y value of 8. So nothing really different there. Part B, the limit as x approaches 2 from the right. So as we get closer and closer to our x value of 2, our y values get closer and closer to the y value of 8. And part C, the limit as x approaches 2. Well, this time, coming in from the left, we got closer and closer to 8. Coming in from the right, we got closer and closer to 8. Since these two limits are equal to each other, the left and right hand limits here, the limit as x approaches 2 of our function is 8. So again, these have to be equal to each other for this limit to exist here. All right, part D, f of 2 is what's the value of the function at x equals 2? Well, there's a hole here. So here's the function at x equals 2. Again, we're dealing with piecewise functions. That function value is 4. So That about does it for this video. I'll see you